Hello, everyone. Thank you for coming. We're going to be talking about AI and the web. Okay. So I'm VP Product of Bright Data. We are the leading web scraping company in the world, and we're going to be giving you the context of web scraping and how agents interact with the internet and things like that. It seems like these days about 50% of all the tech news in the world is around AI. Some of these AI agents don't play nice with websites. Some websites block them, and we're going to be showing you some of these things and how much traffic they consume and things like that. So I was born in the previous century, 1971, and in 1981 I received my first computer. Now, this is for some perspective. My first computer, my father came back from the UK with a computer called the Sinclair ZX81. Probably very few of you know about it. The ZX81 had 1 kilobyte of memory. You used to connect it to a tape recorder to save your work, and you could actually do things with that. And then you connected it to a black and white TV. And I remember how my parents were so excited when I wrote my first program, which was, as you could expect, 10, print Ariel, 20, go to 10. They thought I was a genius. A few computers came and went, and then the real first computer that we had was actually the IBM PC, with an amazing 640 kilobytes of RAM. One day, a friend of mine came over with a floppy disk. I don't know how many of you remember these things. 5-inch floppy disks. And he told me that he had something amazing to show me. And we installed this, and this was a chatbot. It's called Eliza, and you can actually still play with it on the web. There are emulators for this. And I played with it for a couple of hours, and it was amazing initially, until I found out that it was very repetitive, and in fact I was able to kind of reverse engineer the logic. It was basically very stupid. So you can see here in the emulator, I'm saying, it's asking what's bothering me. I'm saying that I'm bothered by global warming. How long have you been worried about? A few years, and then it just goes into something. Does this, talking about this bother you? Something silly like that. So this is just to give us some perspective, because as VP of Product in Bright Data, I do see how far we've come, which is a lot. So let's talk about these things. So Bright Data is the web leader in the public web data space. Public web data means collecting at scale, I'm talking petabytes, information that's available on the internet for everyone. So without username, without password, things like product prices, reviews, legal documents, and things like that. We were really the first company doing this, so we have many, many patents. And the challenge for doing this is actually doing it at scale. We're not a startup. We're about 400 people, and we serve about 20,000 customers, including many, many of the names that you know. If you booked a hotel or a flight or bought something or went on some kind of price comparison site, most likely we were processing the backend for that. So this is Bright Data in a nutshell. And as part of being the first to market, we were ahead of the game also in terms of the legal framework. So in the early 2023, something like that, we were sued. Okay? We were sued by Facebook, Meta, and Twitter. So this is what happens when the laws are not really clear yet. And this was before Elon Musk became president, and it was when Mark Zuckerberg had a completely different hairstyle. The funny thing is that Meta was actually a customer. They were using Bright Data to scrape. But then another department of Meta decided that it's not OK for Bright Data to scrape Instagram. So that was basically the claim, that we're not allowed to collect publicly available data. I remind you, this is publicly available to everyone. And the same for Twitter. And we invested a lot of money in this. Okay? Many, many lawyers made a lot of money off of this. And we won. Okay? We won both claims in California, a federal judge. And this is important. This is important for the future of the industry, just to set precedents, to say what is allowed, what's not allowed. So that's basically our story. So let's talk about AI. So we heard some talk here about agents. Some agents can work independently, but many agents need to interact with the internet. And when they interact with the internet, effectively they are like web crawlers with a task. They need to do something. So we are in the business of crawling, and that's why it is very relevant for us to talk about agents in the web scraping context. So to have an AI agent, you basically need three main things. You need to have an algorithm, you need to have compute power, you need to have access to data. So like the panel here talked about earlier, there are many open source models that you can use. Okay? This is not something that you need to start from scratch. Open source models are available. DeepSeek actually showed us that it's quite possible to train models at a relatively reasonable cost. You don't need to have hundreds of millions of dollars. And the remaining part, therefore, is data. So data is kind of the oxygen or the fuel of these models. And it's also very hard to obtain. If you think about this, Google has access to a lot of data. Microsoft has access to a lot of data. But if you want to start opening some kind of business or create a new, develop a new agent, then what kind of data do you use? So that's basically where we will be coming in and explaining this. And this is a quote from Mark Benioff. He's the legendary CEO of Salesforce, where he basically says the same thing. DeepSeek introduced a new model. There is no need for NVIDIA supercomputers. The real value is in the data. So what we think will happen in the next 2 years is that there will be a need for more data. There will be more agents, obviously, and there will also be more blocking, because many of the websites are not really happy with agents, at least in today's world, until these things will be defined. Let's talk a little bit about scale, and if you remember the 1 kilobyte from earlier, it's going to come back at the end of the talk. So every day we collect a ton of data. Basically, we scrape the internet. Okay, 20,000 customers generate a total of 28 billion requests to millions of new domains. This allows us to collect 2.5 petabytes a day, okay, and which gets translated to about 500 million pages, and then to a bunch of URLs for video, audio, image, and text tokens. If you can squint, you might be able to make out some of the companies using this information, basically pulling tons of images, audio files, video files from the web to continuously train their models. The interesting thing is that we actually cache this data. So we have a huge archive of basically the internet all the time. And this is something that can be used on a very large scale to train big models. But as you will see in a second, you can also use the systems interactively for agents that have to do real-time tasks. So we said that there will be more agents, and I don't think there is any need to go into all of these logos, but we see this as a company because people come to us. So startups get funding for new agents and initiatives, and they come to us because they need the data. We see the demand. In many cases, the free data set, common crawl, is not good enough, or they actually need real interactive sessions for their agents to work. And therefore, they come to us, and we see this, and we think that this trend is going to continue. But agents are cool, but I think that every one of us has seen at least one version of these screens during probably the past week. And we know this firsthand because we have been solving this problem from day one. Okay, web crawling automatically comes with this kind of thing. By the way, even Bright Data uses bots. Okay, sorry, uses CAPTCHAs. Okay? We use CAPTCHAs to prevent fraudulent sign-ups to our platform, and people try to create thousands of accounts a minute. It's acceptable. Right? We understand that. And I think that it's possible for large companies to have maybe an agreement between themselves to allow access. I don't know, so some large company to have access to Amazon so they won't be blocked to facilitate. But if you are a small developer, you probably won't have that luxury. So you'll probably get blocked. And the blocking happens usually with CAPTCHAs. So the CAPTCHA has an interesting story. It started in 2010, as you probably know. I don't know if you know, but it's the guy who invented, who later became CEO of Duolingo. He's the guy who invented CAPTCHAs. This was initially to improve OCR for books, and then it became better with some reCAPTCHA. Then it became invisible reCAPTCHA. Then it started looking at browser fingerprinting. And what we're seeing these days is actually AI-driven CAPTCHAs. So the AI on this website side tries to understand and learn and adapt and actually show different CAPTCHAs to different people based on their behavior. So it's getting harder, but that's part of life. In Bright Data, we have a team that actually maintains what we call the Web Unlocker solution. Web Unlocker, we're not very good with names. It unlocks websites. Okay, that's what it does. And this team comes from companies like Cloudflare, Akamai, Datadome, stuff that you probably know as the blockers. And we have seen a consistent increase in the demand for the Web Unlocker, but in the last 2 quarters or something like that, it has started to really explode. This is in terms of petabytes. Doesn't really matter what the actual number is, but you can see the growth. And we actually think this is going to continue. Okay? It's going to continue because there will be more agents doing more actions, and we think it's going to continue. So, I don't know, I assume that you've all heard about ChatGPT's operator. So we have a couple of people in the company that pay $200 a month, and we play with it. Okay? So here's an example. Buy me the best camera under 1,000 from Amazon.com. It launched the browser, and it got blocked on Amazon. Okay? Probably because they use a data center IP many, many times, and Amazon's web server determined that it was a bot. So it's kind of funny to see this happening. This specific case might not continue in the future because there may be some agreements here. But again, if you are on your own, you're in a different spot. There are other assistants like Perplexity Assistant and things like that. And of course, more people are developing more of these solutions. So I think that we need to rethink how agents need to connect in this new era. And I want to see and talk about how you can make your agents work reliably with these websites which keep changing. So to access content at scale, you need to overcome many things. And let's go from left to right so we can go over that. So the first thing you need to do is to have an IP address that makes sense for your application. For example, if you have a French user, the website expects to see a French IP address. Okay? And it expects to see the browser set to French with all sorts of HTTP headers and things like that. If you try to scrape a French site with an Indian IP address, more than likely you will get blocked or you will capture or get some other things. So first thing is use a proxy, and we have millions of those, to find the correct location to go from. Then you need to make sure that your browser has the correct fingerprint, including all sorts of things like what kind of GPU it uses, what kind of keyboard layout, all sorts of things that the website will recognize. You do this to try to avoid CAPTCHAs, okay? You try to avoid CAPTCHAs, but if you have CAPTCHAs, there are ways around that. After you've gone through that, you need to behave as a user, okay? For example, don't type too quickly. Don't do things that don't make sense from a site perspective. And if you do that and you don't get limited by rate limiting, hopefully you won't be detected. And the interesting part is the false information. So I don't know if you know, but the highest degree of blocking is actually not blocking, but giving you false information, which is a very hard problem to solve because you don't really know how to identify that. So the idea is to try and avoid CAPTCHAs. And here we have a framework that was written by a good friend of mine. And as you can see, A, B, C, D, E. Very important. So the first thing is access. If you want to be successful in having an agent, you need to have access from the correct location. And you want to then mimic the behavior to look like a human user so that you won't get blocked. Once you have the data, you need to structure it, you need to parse it, you need to clean it, because HTML is very messy. Sometimes the data that you initially look for in an agent will only lead to the conclusion that you need to find additional pages. So you need to discover additional pages on the site. That's another pillar here. And lastly, you need to do all of this in an ethical way. So you need to do this while adhering to privacy guidelines. You want to do this without putting the site or the user experience at risk in any way, etc. So let's go one by one. Access. Let's say that I have an agent that helps people order pizzas. Okay? Clearly, if someone is in New York and you send a request to Google to find pizza places, you want to do that in a way that people will get results in New York and in English. But if you're doing that in Amsterdam, then you want to do that in a way where the people they will get, results in Dutch and in Euro. Sometimes going even as granular as the city level, not even the country level. So that's access. Now CAPTCHA. I think we said that the best thing that you can do is to try to avoid the CAPTCHA in the first place. And you can do that by, again, using a correct IP type, using HTTP headers, which the site will expect, browser agent, fingerprints, etc. But in some cases, you have to address a CAPTCHA. So I think we have a video now. What you're going to see here, hopefully. Guys, are you playing the video? OK. So this is an agent that looks at Amazon for prices for a product. You can see it enters the name of the product. It runs, and it will hit a CAPTCHA. The first attempt, we failed. OK. Second attempt, we're going to work on this CAPTCHA. And since this is a video, I know it will work. Success. We have been successful in solving the CAPTCHA. The page will load, and look at the text box. You're actually typing in the words. This is obviously with browser automation. Typing in the words, getting the results. The page is loading, and now we have scraped the results successfully. Okay, so CAPTCHAs can be very difficult. There are different solutions to fixing them. We try to avoid them, but it's part of life. So we have been successful at getting the HTML. Okay, that's like phase one. What now? You need to make this HTML into usable data. So start by parsing. Take an HTML page and basically convert it into a CSV table. Okay? So you can do this in a traditional method of mapping specific fields like price, review, or something like that into the different fields. Or in some other cases, especially when the pages change frequently, we need to use LLMs to identify the page and adjust this schema on a real-time basis. Once you have a CSV table, you want to start cleaning it. I'm not going to even try to pronounce that word. But you want to convert each data to the same format. So for example, if you have different date formats, 1 Jan, 001, 25, or 2025, you want to have kind of a clean data so that you can work with. And then, of course, after that, assign kind of a unique value that people will, so that the agent will be able to easily sort and find the information. If you need to do some additional discovery, that is to say, the result of the agent was you need to find more information on the page, on the site, you need to do some crawling. And here you have basically three methods. This is the easiest one, sitemap crawling. There's a file called sitemap.xml. If the site has that, and not all sites do, you can basically have a list of all the pages on the site. If the site doesn't have that, you can do what we call recursive crawling, which means go to a link, start going left, right, up, down, try to find your way around the website. And this works, but it could miss some pages, because sometimes links are generated after JavaScript is rendered on the page. And then, of course, there's also the option to do this with search engines. That is to say, you put in the search query, look at the links, and try to go from there as well. So we talked about the need to do this in an ethical way. And like Spider-Man says, with great power comes great responsibility. So when you do scraping, especially in our level, our scale, you need to be careful, because you can actually damage or cause damage to websites. So we do this very, very carefully. Doesn't matter who does the scraping, any of our customers, you, anyone. Before starting scraping a website, we measure the response time of the website. Then we start slowly. And as scraping goes on, we continuously monitor the response times of the website. If we see that there's any degradation, we stop. And we do that because we never want to have anything noticeable for the real end users of the website who are actually trying to maybe make purchases or find information. So if there's any problem, we stop. Otherwise, we continue. This is, the technical part of the ethical scraping. And there's also kind of the legal part. So first of all, we only scrape or allow access for agents to publicly available web pages. Okay, no login. So everything that can be freely available to anyone. We don't allow any kind of suspicious activity. We disable thousands of accounts every month for people who try to do funny stuff that we don't like. We do have some specific cases, and then we have a very strict process where we interview the company and make sure that they are legit. And we do all of this in a GDPR, CCPA way, sometimes by mistake. You scrape some PII, you get someone's email, someone's phone number, we reach out, we tell them, hey, we have this information, you can remove it, and some people do, and it's fine. So to summarize, if you want to have a robust way of getting information from websites for your web agent, you start with basically browser automation. You need to access from the correct location, set headers, set cookies, manage user agents. All of these things are trying to avoid CAPTCHAs. If you do get captured, you need to solve it, and then do the rest as a real user to have the outcome that you want. All of these parts are available in BrightData as a complete solution, but also as modular solutions. So we have another video now. Why is my... Yeah. Can you stop? Can you stop for a second? Stop it. So what I'm going to show you now is actually a BrightData customer. It's a company called uTori. They used to, these were guys who worked in Meta, in the AI department, and left. And this is an agent that they bought, that they released. They actually went out of stealth a couple of weeks ago, so they allowed us to use this. And this allows people to basically describe what they want to eat, and it will look at different websites and order the food for them. Okay? So now you can play the video, please. So you can see the query. You check which place has some kind of sushi. And this agent is going to open web pages and do all sorts of human-like actions on the page. So it's searching for different restaurants. And then you can see it's actually typing in the different boxes. Okay? All of these are actions. So scrolling, clicking, another session of typing here, more typing, trying to find the correct or the best fit. You can see it being updated on the left. It found the best restaurant, looking for salmon sashimi, which is good. And then this is added to the cart. At this stage, people still need to complete the order manually, but in the future, they will just be able to have all the details initially in the platform so that they will be able to do this with one click. So, so this is uTori. I don't know if you see this because it's being blocked by the sofa, but every month we process in BrightData between 7 to 10 billion actions. So actions are like scrolling, clicking, something like that. And to put it, people have problems with big numbers, very hard to comprehend. In the time that we spent on this slide, we did probably over 500,000 actions, okay, for different customers doing scraping or blocking, etc. So this is big. So to summarize, I just want to go back to my ZX81 because I did have to use ChatGPT initially, finally for something, and I was very curious because this is was a very small machine. It was about 5 centimeters tall. So I asked myself, if you took 5 centimeter tall machines and you stack them on top of each other, each one of them can hold 1 kilobyte. That was the memory that we had at the time. And you put into this the 2.5 petabytes that we get from the internet every day. How big is that going to be? So ChatGPT did some calculations, which I, by the way, checked, because you can never be sure. And so every day, if you stack these, you would get 125 million kilometers long stack of ZX81s, or they would go around the Earth 3,000 times, which is just amazing. Yeah. So that's about it for me. I want to thank you for listening. We love developers. We love working with developers. We have a SaaS that's effectively built for you to sign up and use immediately. We have a booth just right behind you there, and you're welcome to come out and get $250 credit to start your project with us. And we can continue the conversation there. Thank you very much.